Okay, hello and welcome. Do you ever think of this as what the distance of 5 miles is? 5 guys mean miles, that's the distance. Okay, today we're going to talk about distance and displacement. Sound similar, related, but we need to be really clear on what the difference is between distance and displacement. Okay, so let's pretend that you're going for a bike ride and you're just interested in getting some distance in, right? Distance. So you just take this winding path all over here, and this is where you finish your ride, right? So we can see that you traveled all of this, but when we compare your starting point and your ending point, we see that you just went from here to here. So that's the difference between distance and displacement. So you may have traveled 10 kilometers in your winding journey all the way over to here, but your actual displacement was only 3 kilometers. It was only 3 kilometers over here. So what do we mean by that? So here's some definitions you should take notes on. Distance is the total length between any 2 points. So it's you started here, you went here, 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 and you ended here, and we would add all of that up. And it has nothing to do with direction. There's no direction involved when we're measuring distance, which is why we call it a scalar quantity. Scalar quantity. Scalar is a physics term, and it means a quantity that has no direction. There's no direction involved in it. It's just a scalar quantity. So distance, that's whatever the total length ended up being, doesn't matter what the direction is. On the other hand, displacement. That is how far an object moves away from where it started. How far it moved from where it started. And there, direction does matter. Direction does matter in displacement. That's why we call it a vector quantity. And in physics, a vector quantity is a quantity with some kind of direction. So displacement, it has been moved from its origin, but we wouldn't just say it's been moved by 1 kilometer. We would say it's been moved by 1 kilometer to the east, or to the north, or up, or left. You have to give it a direction, because it's a vector. So we can represent distance just with a plain old number and a unit. However, displacement needs a number, a unit, and a direction. It's customary to draw a vector as an arrow with a label. Here's another example of the difference, and then we'll see how we write them. So let's say this is your journey from home to school, and there's houses and buildings in these yellow squares. You have to walk on the sidewalk along the street. And so you go half a kilometer here, half a kilometer here, half a kilometer here, and half a kilometer here. And that, if we add it all together, that's your distance. But that is not your displacement, because that is not the total amount that you are moved from your house, from where you started. So this is what it would look like if we were writing it out. So you walked a total of 2 kilometers, right? You walked a total of 2 kilometers. But your displacement, how far you were moved away from your home, is actually only 1.4 kilometers, and it's in this direction. So if we were describing this direction, we might say that this is something like northwest, right? 1.4 kilometers northwest. But with a vector, we can simply draw an arrow. Draw an arrow and give it a unit, 1.4 kilometers. And we know it was going that way. So that's how we would write displacement versus how we would write distance. And it's important to know distance cannot be negative. It always has to be greater than 0. You can't walk negative miles. Whatever distance you cover is going to be a positive non-zero number. But displacement can be positive or negative because it involves a direction. Directions can be positive or negative. So what we do is we generally set some direction as the positive and the opposite is negative. Customarily, that means that north and east are usually positive, south and west are usually negative, right is usually positive, left is usually negative, generally speaking, but you set it. And so here's an example. This person, if their starting point was where this lamp is, this would be a displacement of positive 2 to the right, but this would be a displacement of negative 1 to the left, because we said that going to the right is positive, so going to the left becomes negative. It actually can be negative, and that's going to be important. We're going to actually use that in graphing. Okay, I hope you enjoyed that. That was a quick one. See you next time.